All right, good morning. So today we are going to go over some compound inequalities. So compound inequalities are those inequalities that are separated by an and or an or sign. So for example, if I have this problem here like in number 1 and there's an or sign in the middle, essentially I'm doing two separate problems here, and I'm just going to graph the two answers on the same number line. So for the first one, I'm going to subtract my 1 on each side to get that n by itself. So I have n is less than or equal to -4. And I'm going to put a closed circle because I have a little equal to there. And all the numbers less than -4 are to the left. So that's how I'm going to do that side. Now when I go to do the other side of my problem, I'm going to do, I have -4n is less than -8, and I'm going to divide by -4. Now remember, when you divide by negative with an inequality, you need to reverse the direction of the sign, and a -8 divided by -4 would be a +2. So now I'm going to have an open circle at my 2, and I'm going to be drawing my arrow to the right because n is greater than 2, and all the numbers greater than 2 are to the right. Now, if you remember that little tip that I had talked about in class, if you have your variable on the left and only when it's on the left, then your little inequality sign is sort of pointing the direction that you're going to shade. Okay, so number 2, this one here is also an or problem, but we have a fraction. So I'm going to go over this one because I know fractions can kind of throw people a little bit. Now, if I want to get rid of my fraction here, since I'm dividing, k divided by 4, the inverse operation there would be to multiply by 4. So in this particular case, after I do that, I'm going to get k is greater than or equal to 4. Or I'm going to do the other part of my problem here. K over 3 is less than or equal to -1. And there I'm going to multiply by the 3. So now when I do that, I get k is less than or equal to -3. So now when I plot these both on my number line graph, I'm going to do a closed circle at the +4. And since k is greater than that, I would go to the right because 5, 6, and 7 are greater. K is less than or equal to -3, so a closed circle at -3, and all the numbers less than that are like -4, -5, and so on. So I would shade to the left. Okay, so when we look at the next two problems, these are going to be and problems. And you can recognize an and problem because you'll see two inequality signs. So I don't know if this will work here. My highlight, oh, there it goes. So there's my two inequality signs there. So you can kind of see, okay, wait a second, I got two inequality signs. What is going on there, right? So whatever you do to one of these, so usually you're going to start with the middle and figure out, okay, how do I get that x by itself? You have to do that to both the left and the right side of the inequality signs as well. So for this one, I'm going to divide by 2 because I want to get my x alone in the middle, and then I'm going to do that to both the left and the right. So I have 1 is less than x, which would be less than 3. Now when we write them in this combined format, our variables should be in the middle, and the number that's smaller should always be on the left, and the number that's bigger should always be on the right. So this one's set up nicely. 1 is obviously smaller than 3. Now we're going to do open circles on the number line at both of those points, and because x is in the middle, and we can see the two less than signs, we know that that means x is greater than 1 and less than 3. So all the numbers that are greater than 1 and less than 3 would be in the middle of those two numbers or in between those two numbers. Okay, so for number 4, same kind of idea here. So you'll notice that we have our two inequality signs. And the highlighter doesn't always work, so I don't know why it's not working here now. All right, so we have 6 is less than or equal to x plus 6, which is less than or equal to 11. So I want to get this x alone, so I'm going to have to subtract 6 from the middle, which means I will also do it from the left and the right. Now 6 minus 6 is 0, and we have to write the 0 because there's nothing else there. Like if there was an x there or something, then we wouldn't have to. Over here we have x plus 6, and the 6's are going to cancel, so this is like what I'm talking about. You don't need to write x plus 0 because it's still just going to be x. And then 11 minus 6 would be 5. So this would be my answer here. Now notice this time they're going to be closed circles because I have the little lines underneath. So the 0 here, the 5 here, and x would have to be in the middle of those two. And that's it. Okay, so let's take a look at a couple more. So if I look at number 5, I want to do this one because we have some negatives in there, and sometimes that can be a little tricky. So for this one, I'm going to want to add my 5 to all 3 of these. Now, negative 3 plus 5 is 2. In the middle, my 5's cancel, and I'm just left with my m, and then negative 1 plus 5 would be 4. My smaller numbers on the left, my bigger numbers on the right, my two symbols are both facing the same way. They have to be facing the same way for it to be an and problem, and you always want them pointing to the smaller number and opening up to the bigger one, which they are. So an open circle at the 2, another open circle at the 4, and then I'm shading in the middle because m is a number that's in between 2 and 4. Okay. All right, so I'm going to try to just skip down a little bit. So I'm going to go to, let's go to number 8. All right, so if I go to number 8, I have an or here, so I'm going to treat this as 2 separate problems. So the first one, the 9 plus 2b is less than 7, getting that b by itself. So subtracting 9, this gives me a negative 2, dividing by 2. So b is less than negative 1. Or we can do the other side here and find out the other option. So I'm going to subtract 7. Now be careful here, you're subtracting 7 from a negative, so you're actually going to get negative 15. And then you're dividing by a negative 5, and when you divide by a negative, you're going to have to change or reverse the direction of that inequality sign, and a negative divided by a negative will become a positive. So this time I have b is less than negative 1, so I do my open circle at negative 1, and all the numbers less are on the left. Or b could be greater than 3, so open circle at 3, and all the numbers greater than 3. Okay. So we're going to go on to the back now. I'm going to do a few more. Okay, so let's take a look at number 13. Number 13 is a little bit interesting because instead of writing it into that one form where just the variables in the middle, they set it up with the and word like that. So it's a little bit different. So I'm going to actually do that up here. So I'm going to start out by solving these as 2 separate problems like we do in an or problem, and then look at the answer and see if it can be written or combined together. So the negative 10 minus 2b less than 6. We're adding 10 to both sides. So negative 2b is less than 16. Divide by negative 2. So I end up with v, and I had to reverse my inequality, and negative e. Okay, so that's one part. Now let's do the other part. So the other part here was 6v plus 12 is less than negative 6. So subtracting the 12, get that v alone. It gives us negative 18 over here. Divide by 6, and v is less than negative 3. So now if I look at this, v is less than negative 3. Well, negative 3 is here, and I'm going to go to the left. But v is also greater than negative 8, so that's going this way. So because the 2 arrows are going towards each other, and we know that this was an and problem, I could just put v in the middle. What number is smaller? Negative 8 What number is bigger? -3, and then I could make sure I put in my 2 less than signs. They're always going to be less than signs if you have your smaller number on the left and your bigger number on the right. So then there's no confusion about which way do the signs go. They always 100% of the time have to face the same direction in an and problem. And if you set it up with your smaller number on the left, the bigger number on the right, they'll always go in the L direction. So you'll know. Okay. Let's take a look at number 14. Okay, this is an OR problem, so we're doing our 2 separate problems here. So 2x minus 3 is less than 11. Adding the 3, 2x is less than 14. Dividing by 2, x is less than 7. Or, if I do my other equation here, inequality I should say, we're adding the 10. -8x is less than -72. -8. X is less than positive 9 here, but actually we need to reverse our inequality sign because we divided by a negative. So that's the other one. So x is less than 7, open circle to the left, or x is greater than 9, open circle to the right. All right, so I'm going to skip down now. Let's go to 16. Okay, again, this is an and problem, but they're written separately. So let's see what happens with this one. Now, in this particular case, I have a's on both sides of my inequality. So I have a variable on both sides, and I also have a constant on both sides. So, it's up to you whichever way you want to work around. I'm going to just consistently bring my variables to the left, even if they're negative, because with inequalities, it just helps with the graphing. So this would be a -7a plus 8 is greater than 15, minus 8, -7a is greater than 7, divide, and a is reverse the sign, less than -1. Now when I go to do my other side here, I have 13 minus 14a is less than or equal to 13 minus 3a. Again, I'm going to bring my variables to the left just to keep it consistent. So I have 13 minus 11a less than or equal to 13. Now I'm going to subtract my 13. Now, just because I already had a 13 and I subtracted 13, that just equals 0. So don't let that confuse you. A lot of people get all confused and think it means something else. And then I'm going to divide by -11. 0 divided by anything is 0. So now, if I go to graph this, a is less than -1. So here's my -1. Here's the less than. And a is less than or equal to 0. Okay, so we don't really need, now it's saying and, so it's saying a is less than -1 and a is less than or equal to, oh wait a minute, I forgot to flip my sign on there. No wonder. Then it says a is greater than or equal to 0. So less than -1 and greater than or equal to 0. Well, unfortunately, there is no number that I'm aware of that actually meets both of those criteria. If you can think of a number that's less than -1 and greater than 0 at the same time, well, then that's pretty amazing. But as far as I know, there are not any that exist. So because we had an and in here, and this doesn't make sense because we're getting 2 separate number sets, this would mean that there is no solution to this problem. Okay, and finally, we're going to go on to number 20. This is an OR problem here. X plus 18 is greater or equal to 8x plus 4. And then we'll do the other side as well. So first I'm going to bring all my x's to one side. -7x plus 18 greater than or equal to 4. Now I'm going to subtract my 18 to the other side. Negative 7x is greater than or equal to negative 14. And then I'm going to divide by negative 7, which is going to make me reverse my inequality sign and get x is less than or equal to 2. Or the other side of my problem here, I'm going to bring my 15x over, but then they both cancel and I'm just left with negative 15, which is less than or equal to 5. Now that is true, so that means that x can be infinitely many solutions. Now, it doesn't really matter that over here you got x is less than or equal to 2, because on this side it said or x is equal to infinitely many solutions. So that means you can have any number be a solution. So as long as you get one of the two that say that, the other one is irrelevant because the other one's going to say x can be this or x can be greater than that or less than that. It doesn't really matter because the other one's already saying x can be anything. So when that happens, you're just going to say it's all real solutions or all real numbers. All right, and that's it for reviewing our compound inequalities.